Today we're going to deal with another topic from chapter 6, rational expressions, and we're going to look at multiplying and dividing. And that's going to share some of the things you learnt last time. When you want to simplify a fraction, you would factor it, cancel, and then what's left would be the simplified version. Multiplying and dividing rational expressions, and towards the end of that process, do virtually the same thing. So you're going to be quite a big overlap from what happened in your previous chapter 6, the intro one. So let's delve right into the first topic, which is how do you multiply rational expressions? Before we get into those questions, let's kind of take a step back and look at some properties of powers, and essentially multiplying and dividing them, and what do you get? So here are some rules for you. If you take x to, say, the power of a, and you multiply it by x to the power of b, you essentially can combine them into a single power of x by adding powers. And let me nip over and show you that. So just a quick recap, we're going to do multiplying rational expressions, and we have this guy times this guy is equal to x plus b. Now if you want to take x to the a and say divide it by x to the b, then the power of x you get is a, take away b. So if we call this guy a, we call this row b. An example of a might be x cubed times x to the 5. And when you multiply those two together, the single power of x you get is x to the 8. Not 3 5s are 15, but 3 add 5 is 8. And let's take an example of b. If you had x to the 7 and you divided it by, let's say, x cubed, the answer you would get is 7, the first guy, take away 3, the second guy, and that would be x to the 4. Division can be written in two distinctly different ways. You can also do division by writing it like that, and that is the equivalent to the numerator divided by the denominator, and so the answer would still be x to the 4. And so those are the basic rules for multiplying powers of x or dividing powers of x, and we're going to incorporate these rules with various under various circumstances. So let's expand this idea a little bit further. Suppose we introduce two variables, so 3a squared b cubed is going to be multiplied by 2a to the 4 b squared. If you want to multiply these two together, you basically break it into 3 different multiplications. So you can only really easily, at least, combine a multiplication of one variable with someone else in that same variable group. So 3 times 2 gets me 6. This guy times that guy, add the powers, you get 8 to the 6. And this guy times this guy gets you b to the 5. So far, so good. Now, you can get some quite interesting results when you divide. So for instance, suppose I had 16 a cubed b to the 5 on the top, and on the bottom I had 14 a squared b to the 7. Now you would split these up like this. So each of these are going to get divided by the equivalent power underneath. Now 16 and 14 don't really give you much, but you can get 877. Now an a cubed and an a squared gets you 3 take away 2, and a b to the 5 divided by a b to the 7 gets you 5 take away 7. You have to be a little bit aware of what's going on here. A to the power of 1, technically, and then a b to the power of -2. And we have conventions, rules, if you like, that tell us the best way to write things like this. So a to the 1 is just considered a. B to the -2 can be thought of as being b squared on the bottom. And this would be considered the simplest version of this particular calculation. Now you're going to be doing a lot of, at the beginning, questions with more than one variable, and this is kind of the process that we're going to use to get to that result. Now you put it together and you get quite large and complicated questions. So for instance, here is an example of a question that looks like and there are a number of different ways to approach this. This here is a little bit crude, but it works. So the first thing you do is just multiply everything in the top together using the rules that we already know. So if you multiply this and this together, all you really get is 4 times 20 is 80. There's an a squared, there's a b to the 8, there's an x squared, and finally there's a y to the 4. So in this particular case, there wasn't really that much combining going on. In this bottom case, we have a lot more going on. We have 8 times 16, which is 128. We have an x, a y to the 4, an a squared, and a b. Now what I'm going to do is I'm going to separate them into individual pieces, each with the same variable top and bottom. So for instance, I have 80 over 128. The brackets are just for emphasis, you don't really need them. Now, if I'm going to do a squared on the top, I have to look in the bottom and there's an a squared there. And the next cell I'm going to do is b to the 8. And if I look hard enough, I find a b on there. And the next one is going to be the x's. So I have an x squared there, and I have an x here. And the last one is y's, and I have a y to 4 here, and a y to the 4 here. Now, each one of those will then be simplified, and then we can combine everything together. Now, 80 over 128, I'm sure it simplifies. 80 divided by 128, then hit the math button and choice 1, and it turns it into the fraction 5/8. So that guy is 5/8. Now, a squared divided by a squared is a very special case, because essentially you would get 2 take away 2 is nothing, and 8 to 0 is 1. Or you could think of it as that cancels out that totally, and if you cancel out things completely, you leave a 1 behind. And in this next one, you have an 8, right, b to the power of 8, and just a b. Although we don't write it, when you see b on its own, it means there's 1, right, b to the power of 1. So this is 8 take away 1, which gets me 7. And this is an x squared with an x to the 1, so that gets me an x. And this guy here gets me a 1. So when I put all this together, I get 5/8 b to the 7 x. And that's our answer. So a fair amount of work in just one question, right? Let's look at another question where we have an extra step. So this is a version of question 2. So we're going to have 3x squared plus 6x. And on the bottom, we're going to have 8x squared take away 64x. And that fraction is going to be multiplied by 6x cubed, take away 48x squared. And this guy here, he's going to be 2x squared plus 4x. Now we are going to multiply the top together, multiply the bottom together, and do all sorts of usual things. But before I even attempt to do that, and I'm certainly not going to distribute anything, is I'm going to look at this and say, look, you can pull out a common factor of 3x, and that leaves you with x add 2. And you can pull out a common factor, in this case, of 8x, and that leaves you with x take away 8. And you can pull out a common factor of x squared. Actually, you can pull out a common factor of 6x squared, and that leaves you with x take away 8. And this one you can pull out a common factor of 2x, and that leaves you with x add 2. And so you should, in these questions, right, that contain multiple powers of x, different powers, polynomials, factor the top and factor the bottom. Then you can combine them. If you multiply these two together, you will get 18x cubed, and then an x plus 2 and an x minus 8. So these two give me that, and then these two just follow. Now on the bottom, these two give me 16x squared. Then I have an x take away 8 and an x plus 2. And in these questions, you essentially have done factor and now cancel. So let's see what we can get as far as cancelling goes. That guy cancels out that guy. This one gets cancelled out by this one. 18 and 16 do simplify down. And I'll try it on the calculator. I should be able to do my head. 18 divided by 16. And then math choice 1. And you're looking at 9/8. So you have 9/8. X cubed and x squared also cancel, but 3 take away 2 leaves you with 1x, and that looks a bit weird, so I'll rewrite it again. How about 9/8x? And so that calculation actually simplifies down to just that, which is kind of the benefit of being able to do this process, where you can do two things multiplied and get a very simple answer. So let's try another one. Suppose I had x squared take away 4 over 3x minus 9. And I wanted to multiply that by x squared plus 4x plus 4 over x take away 3. So what I'll do is I'll factor what can be factored. You can't really do anything with x minus 3, so I'll do that. This fella here is called the difference of two squares, and it gets you those two as its factors. And you can check it, but that works. This one here has a common factor of 3, so I'll do that. And this guy here, two numbers that multiply together give me 4, but when I add those two numbers, I also get 4. That ends up being x plus 2 times x plus 2. So that's step 1. And that is factor, right? Factor everything before you think about multiplying. Now, you can actually save a line of working here, because you'll notice once you've done a few of those that you don't need to combine them into one single fraction. You can just basically take anybody in the top and do a 1-for-1 cancel with anyone in the bottom. So for instance, x minus 3 cancels x minus 3. X plus 2 cancels that x plus 2. And that's as good as I can do it. Right? That doesn't cancel, so we're finished. So on the top, I have x minus 2. And on the bottom, I have 3 lots of x plus 2. So what that does is it reduces your workload. So if you factor first, you can then do a one-for-one cancel on whatever's left on the top and on the bottom. Combined gives you your answer. Kind of cool that you can do it so quickly, provided you know how to factor things. So factoring is key to these questions. Here is an example of one last multiplication, number 5. So I have x squared plus 6x add 5 over 4 plus x take away 3x squared. And that's going to get multiplied by a 3x squared plus an 8x take away 16, and then an x squared plus a 5x on the bottom. And so we're going to factor everything first, right, before we do anything else. So two numbers that multiply to give me 5 and add get me 6. That's x plus 1, x plus 5. That's that one done. This is a bit messier. Because it's 3x squared, I know it's going to be 3x and x. And then I'm trying combinations that give me negative 16. So obviously one of those plus, one of those negative. It's 16 and 1, 4 and 4, or 8 and 2, with some combination of one of those positive, followed by one of those negatives. There is an awful lot of choices going out here. I'm trying to see if I can find one that works. Brain's still thinking. Oh, there must be one. Let's see what it could be. 4 and 4. That looks good. If I make that positive, I get 12. Make that negative, I get it. That's the one that's going to work. Now, this guy and this guy factors out as x plus 5. And this guy here, well, here's a bit of a quandary. It's not obvious. So I'll show you how I would tackle this one. If you ever have a quadratic that has a negative in it, as this one does, the usual rules of factoring don't apply. So what you're going to do is you're going to pull out -1 as a common factor. Essentially, that just changes the sign of everybody. And that's allowed. So if I multiply everything by -1, you'd get back there. Next, I'm going to write them in the order that we would expect to see it, just that. Next, I'm going to put a 3x again and an x. And I'm looking for combinations that multiply to give me -4. And then when I do the FOIL, I get -1. And that looks like a 1 and a 4 would work. If you make that negative, and that's plus. If you FOIL that out as a check, it does work. So you just kind of try one, it doesn't work. You try the second, 3 or 4 shots, and hopefully that's it. So now I have the correct factor. So this guy here is 3x take away 4. And that guy is x plus 1. So we're now there. And now we just go hunting for things that cancel with other things. And there's an x plus 5 here that's going to cancel with that x plus 5. There's a 3x minus 4 is going to cancel with that 3x minus 4. And there's an x plus 1 and another x plus 1. So quite a lot was cancelled here. I'm left with an x plus 4. And on the bottom, oh, I'm only left with an x. And this is finished. So multiplication, at least most of them, require factoring everything. And then you can do a one-for-one cancel. And whatever's left is your answer. So the key to doing it is being able to factor things. So get lots of practice at factoring. Look for other examples online. Look at the examples I've given in Canvas. Look at the other video that I've got of this from my previous class. Look up as much practice, as many examples you can of factoring. It's going to make your life a lot easier once you get good at factoring. So we're now moving to the second one, and that is dividing rational expressions. We'll now look at dividing, and it's actually a very similar process to multiplying. Very similar. Show you how you would do it with numbers. You know, fractions that contain numbers. Suppose you had 7/5, and I asked you to divide it by 8/15. Now, you could do that in your calculator, but if you were going to do it the old school way, there's a rule that says multiplications, divisions can be turned into multiplications with the reciprocal. In other words, you turn only this fraction upside down. That's called the reciprocal. Now, when you do that, you can then, hopefully, get some cancelling. These two divide by 5. And then what's left is 7 times 3. And on the bottom, you got 8. And that's your answer. So that's the process that we are going to adapt to algebra, right? Things with A's and B's, and then later on things with X's. Yeah, everyone, let's try this division. 12 a cubed b to the 7 over 5 x squared y squared. And that's going to be divided by 16a b cubed all over 18xy to the 4. Now, there's one extra step in division, and that is essentially take this calculation and turn it into an equivalent multiplication. So you take the first guy, leave them all on, don't do anything to it. Then you turn the other one upside down, which is its reciprocal. So there's a trick that says dividing a fraction is the same as multiplying by its reciprocal. And then what we can do is combine all these things together. So 12 times 18 gets me 216. And then I have an a cubed b to the 7 x y to the 4. And then that times that gets me 80. I have an x squared y squared a cubed b cubed. Now I will split everything into similar terms. There's the two numbers. I have an a cubed on the top, and I have an a cubed on the bottom. I have a b to the 7 on the top, and I have a b cubed on the bottom. I have an x on the top and x squared on the bottom. I have a y to the 4 and a y squared. Now each one of them gets separated or gets simplified separately. So 216 divided by 80 is that guy. Then convert that to a fraction and we get 27 tenths. Now a cubed divided by itself gets you 1. B to the 7 divided by b cubed gets you b to the 4. And x, which is essentially x to the 1, divided by an x squared gives you x to the negative 1, which we can simply just write as 1 over x. And y to the 4 divided by y squared gets me y squared. And if you combine all of this together, you get 27 b to the 4 y squared all over x. And that's it. That's essentially how you do that type of question that contains nothing but various pairs of AB's x and y. Now let's move on to questions involving two variables. So that an example of that would be y to the 7. Now you don't get really any easy versions of these questions. They are quite complicated. There's a lot of things you need to be keeping your eye on. Keep your eye on the ball. So there's the first fraction. It's going to be divided by the second fraction. And this particular question, you can see that it's actually a combination of x's and y's. What I'm going to do in this case is kind of go through a sequence of steps. Step number 1 is I'm going to turn it into its equivalent multiplication. Now, I could do other things at the same time, and maybe when you get more comfortable, you can combine a couple of lines together. But right now, I don't want to do too many things at once. So that's going to be step 1. Convert your division into the equivalent multiplication by taking the second fraction and doing its reciprocal, turn it upside down. Now the next step is factor everything. Now if you pull out a common factor of 4, you get x squared minus y squared, which is good. You really don't need to factor 18x squared y squared because it's already factored. Now if you look at this expression, there's a 2, there's an x, and there's a y. So there's a common factor of 2xy. 2 used up, one of these used up, that used up. So there's an x. 2 used up, x used up, one of the y's. So there's a y. Now this fella is got a common factor of 9. And if you look more carefully, you can see it's got a common factor of 9x. So that gets me x minus y. And that's very nice. I mean, it's well factored, but it's not completely factored. If you ever see two variables, something squared, take away something different squared like this, think of difference of two squares. Essentially what you get is an x plus y, x minus y, over 18x squared y squared times 2xy, x plus y, all over 9x, x minus y. Right, so now everything is factored. We can now save a little bit of work by just doing a one-for-one cancel. What I mean by that is find something on the top that's the same as the bottom. And so I'm looking at x minus y and saying that will cancel. And then I'm looking at this x cancels one of these, but leaves behind an x. This y cancels one of these and leaves behind a y. That x plus y will not cancel with this one because they're both on the top, right? You need something on the numerator, something on the denominator. I'm looking for something else to cancel, and I can cancel that 2 and that 18 by dividing both in by 2. Now, there's nothing else I can see left, so it's 4. There's an x plus y, and then there's another x plus y. And on the bottom, there is a y squared and a 9 and an x. So I would call that 9x. Oh, 9x squared, because there's a square, right? Oh, 9 and 9. Almost made a mistake there. 2 9s is 81. 2 x's multiplied give me an x squared and a single y. So that is our final answer. Let's move on and look at a version of question 9. So it's full of quadratics. So you get a lot of practice at quadratics in these questions. And it's going to be divided by and this is going to be a challenge. This question is going to be definitely a lot of work. First thing I'm going to do is just convert it into its equivalent multiplication. Not going to do anything else here. And now I'm going to factor everything. Every single one of these is the worst case scenario. They are quadratics with more than an x squared, right? 2x squared, 3x squared, 4x squared, that kind of thing. So 3x squared, 3x and an x. Two numbers multiplied together give me -4. And when you FOIL it out, you get -4x. So I am going to try and find a 2 and 2 combination, I believe. And if we make this negative and that positive, I would check it by FOILing it out, and it works. Now this guy in the bottom, he could be a 6x x split, or it could be a 3x 2x split. He happens to be a 2x 3x split, and both of them are positive, and the combination is 3 and 2. And if you want to check it, 3 times 3 is 9x, 2 times 2 is 4x, 9 and 4 gets you 13. This is the only combination that works. Right. This guy here, the 4x squared, could be a 4x with a 1x, or it could be a 2x with a 2x. That combination does work. And we are looking for combinations of this guy. So after a lot of trial and error, we'll eventually get that one, and it works. And this fella here, 45 is a pretty big number, but the combination that works are those two negative numbers. Right, everything is factored. So now I just need to find things that cancel each other. Those two cancel. And those two cancel. And those two cancel. So all I'm left with is an x minus 2 on the top, and then x minus 9 on the bottom. And that's as good as that answer is ever going to be. It's finished. And that is us. So hopefully this has been some help. I can't emphasize enough that you need to practice as much as you can on factoring, right? These guys, for instance, a classic example of that. But if you don't know how to factor them, you're never going to get by this line here, right? You're not going to be able to factor and then cancel. So focus on doing that. And the more you do, the better you'll get. You just have to trust that that's going to be the case. And it is. And I hope this has been some use to you. And bye-bye for now.